Well, if you think about it, you need only three things to you only need three particles to make everyday matter, and they are electrons, up quarks, and down quarks. To make a proton, you need two up quarks and one down quark. And to make neutrons, you need two down quarks and one up quark. And with the protons, neutrons, and electrons, with that, you can always create any particle in the world. And actually, any electron in the world, will ya? And then again, there are way more particles than that, like the pie chart I showed you in the beginning of our series, with 68% of we have no idea, 5% of stuff we know, including pies, and 27% of it being something called dark matter. It's like everything we discovered until now, it's like we've been looking at a tail for thousands of years, and now we realize we've been studying an elephant, and we've only been looking at a tail. Learning this, but then you'd be disappointed. But however, once you kind of think of it, it's not that disappointing at all. It's just something else you don't know, and you can find out. Okay, so as I mentioned in the chart, what is dark matter? Here is a bar chart of the universe. Now, physicists think that 27% of the universe that we think we know about is actually something that they call dark matter. And so, how do we even know it's there? Well, here's the thing. Let me draw a universe. And let the editor animate it. Now, of course, universes spin. And if there's nothing out there and nothing blocking anything, then as it's spinning very faster, and as the galaxy spins, then stars would start to be, strewn out. But we know that isn't the case, as stars wouldn't have fallen out, and if it did fall out, then our sun would already be outside of the galaxy by now. So something heavy must be holding them in there with gravity. But what is all that heavy stuff? Physicists call it dark matter. And as this claim was quite extraordinary, and as the famous astronomer Carl Sagan once said, extraordinary claims require extraordinary evidence. So without being understood as the years went by, the existence of this mysterious invisible heavy stuff, or dark matter as it became known, started to become more and widely accepted. Also, another clue is gravitational lensing. So here is one problem that physicists have found out. When people started looking through telescopes, they found out when they tried to view at one galaxy, they instead found two of them. And they were exactly the same color, the exact same size on the telescope, exactly the same symmetries. Like a symmetry. So then they were sure that these two galaxies were exactly the same. But how can that be? Well, there is one possible solution for this. And so when the light from the galaxies goes, the dark matter instead bends it, so that whenever the telescope is viewed at any of these either points, that you will see the same and exact identical universe. Another thing is colliding galaxies. So basically, a lot of things happen. So when the two galaxies collide, I'll show it here. All the regular matter stuff, like dust and all those other things, crash into each other. But the dark matter stuff, the ones that seem to be like dark matter, instead of going through the air, they pass through each other. Dark matter can't touch itself, and dark matter can't touch the matter. Wow, that's kind of weird, guys. And then there are four major ways that how things interact. There's gravity, there is magnetism, like electromagnetism, using electricity to make magnets, and the weak force and the strong force. So then, how does all that work out? And so gravity interacts with how the dark matter interacts with gravity, but not with the other forces such as electromagnetism, weak force, and the strong force. But then, how do we study dark matter? We can't. Sorry, we hope we can exist that dark matter exists, and something is definitely out there keeping our stars flinging away from our galaxy, and also bending the light so that we see two things. And so dark matter is kind of cool like that. And now let's go to another topic. If you remember that we included dark energy into 68% instead of we have no idea, it turns out there's a lot of things that's happening. But then again, we already know that the universe is always expanding. If you ever heard of the Big Bang, which was basically a little dot in the beginning of the universe, it would have exploded like this. And you know what the weird thing is? It's still growing. I'll just pause the growing phase there. And then again, there are possible phases of the universe. And there's so much stuff in the universe that the force of gravity will eventually win and slow the expansion and shrink everything back down. And this is called the Big Crunch, the emoji that I corresponded with. Another way is that there is not enough stuff in this universe for gravity to slow down the expansion. So the universe keeps expanding forever until it spreads out into an infinitely dilute and cold and lonely universe. And the corresponding emoji is this. And another one is that there is just enough stuff for gravity to slow down the expansion, but not quite enough to stop or shrink the universe back down. The universe keeps expanding, but the expansion slowly approaches zero. And the emoji is this. But then again, everything we think we know about dark energy and what it could be helping to expand our universe could be outdated in the future. And probably future people would start laughing at us, thinking that how could these little people think that was the actual thing that the universe's fate was? I mean, sure, that's kind of ridiculous and so rude. But then again, even further into the future, I mean, yeah, there's so much things to do that I'm not even sure that there will be anything to talk about us. If the universe is expanding more and more quickly because of the dark energy, it means that everything is getting further away from us a little faster each day. And as the expansion picks up speed, that things are far apart will eventually be expanding away from one another, and eventually the future night sky will look like this, without the city lights. And that is all. So I hope to see you guys in the next episode. And if I do see you guys in my next episode, then I'll see you then. Shanann out. Peace. Subscribe to Han Chun Chun.